You might have heard of the divisibility by 9 rule. Add the digits, and if the sum is divisible by 9, then so is the original number. Here is why it works, and how the same trick gives us rules for 11, 91, and even 99. First, the classic divisibility by 9 rule. The whole proof relies on one congruence. 10 is 1 more than 9, so 10 is congruent to 1 mod 9. Write the number in decimal. Each digit is multiplied by a power of 10. Now reduce mod 9. Every 10 becomes a 1 mod 9, so every power of 10 becomes a 1. And what is left is just the sum of the digits. So the number and its digit sum leave the same remainder, mod 9. They're either divisible together or not at all. Try it on 567. The sum of the digits is 18, which is 2 times 9. Therefore, 567 must be divisible by 9. And it is. It is 9 times 63. Same trick, new divisor. 11 divides a number exactly when it divides the alternating sum of the digits. Why alternating? Well, because 10 is 1 less than 11, so 10 is congruent to negative 1 modulo 11. Take the same decimal expansion and reduce modulo 11. Each power of 10 becomes plus or minus 1 depending on the parity of the exponent. This alternates with every digit. Starting from the units digit, the signs alternate plus, minus, plus, minus. Therefore, the number is congruent to its alternating digit sum, modulo 11. Consider the number 1331. It has an alternating digit sum of 0, and 0 is divisible by everything, so the original number is divisible by 11. Indeed, it is equal to 11 cubed. The same idea scales up. To handle 99, note that 100 is congruent to 1 mod 99. So instead of digits, we group the number in pairs of digits and add the groups. For our 7-digit number shown on the screen that we want to be divisible by 99, when we reduce it modulo 99, we split it into the pairs 2, 13, 58, and the unknown last pair, AB. Each power of 100 is congruent to 1 modulo 99, so the original number is congruent to the sum of all of these groups, which gives us 73 plus AB, which must be congruent to 0 modulo 99. A 2-digit group can be at most 99, so 73 plus AB must equal exactly 99. The pair is therefore 26. A is 2 and B is 6. For the final problem, we look at a competition problem from the Harvard-MIT math tournament. We want to find the digit n that makes this long sequence of numbers divisible by 91. The secret is that 1001 factors is 7 times 11 times 13. And notice that 7 times 13 is 91. So 10 cubed is congruent to negative 1 modulo 91. Therefore, we can group in threes and alternate the signs. First, pretend the mystery digit is 0. The groups are 123, 450, and 789. Taking the alternating digit sum of this number gives us 462, which is congruent to 7 modulo 91. Now, restore the digit. It sits in the thousands place, and 1000 is minus 1 modulo 91. So the number is congruent to 7 minus n modulo 91, which must be equal to 0. Therefore, n is equal to 7. Using this one mod fact, and the 9-digit number was quickly reduced modulo 91. Step back, and there is really one central idea in this video. 10 is 1 mod 9 and minus 1 modulo 11, 100 is 1 mod 99, and 1000 is minus 1 modulo 91. If you like these videos, please make sure to like and subscribe for more.